there, I'm your host Dan Rojas, and I have one of the ceiling fan conversions hooked up. This is a ceiling fan motor with neodymium magnets replaced around the outside. If you don't know what I'm talking about, there is a link below that shows you what these look like on the inside, and also there's a link to a channel. Somebody who builds a lot of them, he shows you how to do them. This particular one produces very, very high voltage. You're going to notice that I have this hooked up to a regular AC outlet in your house. This is a very unsafe way of doing this, but for this test, you'll see why I'm doing it in a little bit. Never just have household AC hooked up. The only time this gets power is when I turn it on. So I could knock the crap out of myself if I grab these and hit the drill, but we're not going to do that. By the way, there are two sets of coils in here, and we're just using one of them. We have our meter on the alternating current. This produces AC current similar to what you have in your house. And it doesn't really matter which way you go, although this drill works better in the drive position. So you can see that we went up to over 220 volts. It's enough to definitely shock you. The setup that I have is a simple, there's a magnet under here, and I took one of the saw blades and put it there. This locks on there pretty simply, and it fits in there nice. This is just for testing. It does slip a little bit because the magnets aren't touching to each other. There's a plate in between there, but it works really well if you start off slow and you don't put a really heavy load on it. Over here there is a box which I'm not going to be using in this video, but it has capacitors, it has rectifiers, it converts the alternating current into a usable DC current. It's really a nice setup. I'll tell you more about this in a future video. And over here is the reason for doing this video. These are universal AC adapters. There are a couple different ones that I bought. They're pretty much the same thing as these. This one is 500 milliamp. It's at a 22 volt rating to charge an 18 volt battery. This one has a wider voltage range, input voltage, and it actually is a 90 watt version of this. And you can switch from different DC voltages. So this just plugs into your wall. It's used to charge computers. By the way, don't run out and take your AC alternator and hook it up to a computer or something like that. I'm not telling you to do that if you destroy your computer for whatever reasons. I haven't totally tested this yet, but I just want to show you these charging batteries, because this is a very simple way. If you have a high voltage alternator like this that has a lower current, you can actually run these off of them. I have the alternator hooked to this outlet right here. Again, don't have exposed wiring when you do use anything, even like a gasoline generator, or if you have a continuous voltage to it that's not controllable there, you'll get shocked just the same as if you hooked this to your house and did something stupid like that. So don't do that. What I have is a power strip, and I'm going to just plug it in like a normal power strip would. And I'm going to bring the camera around and show you all the lights on these come on. So I have the meter hooked up, and we're going to see the voltage. This is the AC voltage that it's registering over there. It's plugged in similar to how you would test household electric. This has the little LED there. These all have the little lights. The green one's here and here. So we're going to spin it up and see at what voltage they start to activate. I don't know if you can see that, but the front two, the green lights just came on at a lower voltage. And that's a pretty slow spin rate right there. Maybe 200 RPMs. So now what I'm going to do is I'm going to hook this DC amp meter. It shows current and watts and everything. And we are going to see if these actually will charge this battery. This is just a simple charger like you would use for laptop computers or your house or whatever. This one, I bought this one because it has a 90 watt output, so it's a higher output, less chance of destroying it. And I am just clamping these on. So let's have a go and see how if this charges. Now, if the battery, you see it's dropping to 8, if it gets up close to like 10 or 11, or you can actually see the watts are right here. This is the watts going into it. From right now, nothing's going on because there's no current transferring. This actually does start to torque down. Now I have the big one hooked up to just this meter here. It's hooked to the DC, and that's just what it's stored inside of there. You can see it goes up to 19.82 volts, which is just above the 19.5 that it's designed to charge to. And even if I spin this really fast, it pops my leads loose. Even if I spin it really fast, it doesn't go above the 19 volts. So this should be good for charging this battery. Okay, so this one had some pulsating to it. We were charging the battery, but it wasn't a nice flow. It was giving it an up and down. So now I'm back to the original one, and the alternator in the background. This is just to hold this in place. It's got nothing to do with this test. I just put the switch on 20. Now we're doing 49 watts, 51 watts. So we're charging the battery right now with 53 watts. And you can see the battery voltage held up pretty good. So while I've been getting something else, this battery's been hooked up for about 25 minutes, and it's still holding at 12.9 volts. So it did charge it. It was like 8 before, and it was continually dropping. So I'm going to disconnect this. Alright, so we have everything hooked up. Let's see what happens. So just to recap what's going on here, this is one of the ceiling fan alternators, and it is hooked to this plug, this outlet right here, and we are running it to a power strip over there. I could have just plugged this directly in here, but the power strip makes it cool. So, and I have this set to 15 volts DC. This is a 12 volt halogen bulb, incandescent bulb, and it powered it pretty much with ease, actually. This is an incandescent bulb with a really neat mirrored dome on it. I got it because I was going to take the bulb apart. I'll do that in the future, but right now I'm going to just plug this directly in to our power strip. So we're running an AC bulb on AC from the alternator. Now you don't have to be perfect. These are filaments, so they are a resistive load. They can handle different voltages. You hook something like a motor to this and you get low voltage, you can burn the motor up. So don't hook anything but resistive loads like water heater elements. As long as you don't go above their wattage, you should be fine. But this is hooked directly to this. So you can see how fast I'm going with this. This is direct. I'm gonna turn it. I'm turning it the other way. Hey. Alright, well I just destroyed my drill for you guys, so hope you're happy. So in terms of using a universal AC adapter from an alternator, this is actually the best choice of all the ones that I've tested. I have a link on my website on where I got this. This came from eBay. It was like $18 or something like that. And it works pretty good. I've used it quite a bit actually testing this. I got excited whenever I saw that did work. And the nice thing is you have different voltages that you can switch to on the DC side. You got to see this run a light bulb directly, and in a future video I will be showing you this cool setup here. I'm your host Dan Rojas. Thank you for watching and enjoy our videos.